Hi, g'day. I'm Dr. Karl from the University of Sydney and Triple J, and I'm here to talk to you about science and mathematics. Now, you might think, oh my God, mathematics, what is this crazy stuff? You think to yourself, I am as dumb as a box full of hammers. How can I possibly understand mathematics? You've got to be a genius. No. You see, mathematics is a language. Now, in Europe, they can talk 2 or 3 or 4 or 5 languages. Does that mean that they are 2, 3, 4 or 5 times smarter than we are? No. Same amount of smarts. It's just that they've learned this other language. And mathematics is a language that you have to learn. You want to do mathematics, you've got to do every bit of work along the way. And if you do that, you'll have to work hard, but you'll have a good understanding of mathematics. You can apply the formulas. In most cases, you can get really good marks, and you can at least be competent. And if you're lucky, you might even get a love for mathematics. So mathematics is a language, but you've got to work hard. And knowledge is a difficult load to pick up and put in your brain, but once it's there, it's really easy to carry for the rest of your life. So that's the first thing. Number 2, it also gives you an insight into the beauty of things. For example, with a classic story, the kids always ask their parents, "Hey, Mummy, Daddy, why is the sky blue?" And you need mathematics to understand it deeply, but let me give it to you without mathematics. There's a phenomenon called Rayleigh scattering. What's this thing called scattering? It's a specific physics word that refers to radiation, in this case light, coming in, we'll say, from the sun, hitting particles in the atmosphere, which are the oxygen and nitrogen molecules, being absorbed and then being re-emitted off at an angle. That is what we call scattering. And that's behind why the sky is blue. Okay, let's start above the atmosphere. And you're looking at a packet of 1,400 photons coming from the sun. And of those 1,400 photons, 1,000 will make it all the way directly into your eye, not hitting any single molecules of oxygen or nitrogen on the way down. 400 will do scattering. They'll come down, hit a molecule of oxygen or nitrogen, and instead of going into your eyeball, they'll go over there to your friend. And your friend who is looking in that direction will go, I'm looking over there, this blue light coming at me from the Rayleigh scattering, therefore the sky is blue. That's without the mathematics. Let's dive into the mathematics. Oh my God, it's beautiful. Look at this beautiful equation. Whole lot of stuff. Look, it's got an equal sign, so it has to be an equation. And then there's I and weird Greek symbols and cos squareds and pluses and brackets. And down there at the bottom, down there, is the only thing that varies. Everything else on the right-hand side is pretty well a constant. But lambda is not. Lambda is the wavelength. Now, what can lambda vary between with regard to the colours of the rainbow? Well, blue is 400 nanometers, red is 700 nanometers. So what you do is you get one and divide it by the other, and then raise it to the 4th power. See, it's got lambda to the 4th. Well, 700 divided by 400, then raised to the 4th power is about 10. So what that means, your friend over there, overwhelmingly, they're going to see 10 times as much blue light as red light. That's the final answer. They're looking over there, they're seeing heaps and heaps and heaps of blue, and that's why the sky is blue. And so, just to mess with your mind, the sky is blue, so why is the sunset red? Oh my God, messing with your mind. Have fun with that one, and best of luck with the exams. Have a great time. You need any help in your future academic careers. Can't help you with relationship advice or cooking or clothing, but you need any help with your academic career, give me a ring here at the University of Sydney. Bye.